Assalamualaikum sir, my name is Spike Simran and my ID is 1116565642.
Assalamualaikum sir, my name is Tasmia Shorkar and my ID is 19128444642 and our presentation topic is insertion sort.
Insertion sort. Insertion sort is a simple sorting algorithm that works similar to the way of playing cards in our hands. In case of insertion sort, the array is virtually split into a sorted and an unsorted pair. Also, values from the unsorted pair are picked and placed at the correct position in the sorted pair. Now comes some of the important characteristic of insertion sort. It is efficient for smaller datasets but very inefficient for larger datasets. Insertion sort is adaptive. That means it reduces its total number of steps if a partially sorted array is provided as input, making it efficient. Among sorting algorithms, it is better than selection sort and bubble sort algorithm. Its its space complexity is less, similar to bubble sort. Insertion sort is also requires a single additional memory space. It is a stable sorting technique because it doesn't change the relative order of elements which are equal. Let's go through an example. Here the sorted subarray is red and the key is in yellow and the blue is unsorted which we have to deal with. Because the subarray containing just index 0 is our initial sorted subarray, the first key is in index 1. We insert the key into the sorted subarray to its left. Now the sorted subarray runs from index 0 through index 1 and the new key is in index 2. We insert it into the sorted subarray to its left. We keep going considering each every element in in turn as the key and inserting it into the sorted subarray to its left. Once we have inserted that rightmost element in the array, we have to sort it the entire array.
Now comes the insertion sort complexity, which is of time complexity, space complexity and stability. Time complexity is of three types: worst case complexity, best case complexity and average case complexity. In case of worst case complexity, we go through an example. If an array is in ascending order and we want to sort it in descending order, in this case each element has to be compared with each of the other elements. So for every nth element, n minus 1 number of comparisons are made. Thus the total number of comparisons for worst case stands for n minus 1 plus n minus 2 plus dot 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 3 plus 2 plus 1, which denotes order of n square. Thus it follows order of n square. In case of best case complexity, when the array is already sorted, the outer loop runs for n number of times, whereas the inner loop does not run at all. There are only n number of comparisons, thus the complexity is linear. So the total number of comparisons for best case stands for n minus 1, which denotes order of n. Similarly, in case of average case complexity, it occurs when the elements of an array are in jumbled order, which means neither ascending nor descending. Thus the overall worst case stands for order of n square plus order of n square, which is equals to order of n square. Thus it remains similar, so it stands for order of n square. In case of space complexity, it stands for order of 1 because an extra variable is used over here. And insertion sort, in case of stability, it is stable. And that's all from us. Thank you, sir.
Thank you, sir.